guys, now we're going to go through the bind process and show you how that works. It's a pretty simple process. All you do is connect the V-bar to the control, the V-bar receiver to the V-bar. Make sure you pay attention to polarity because it's different on the receiver versus the sensor, so don't just assume it's one way. You plug in power, and when you plug the power in, what you'll see, that was an OptiGuard flash, not a big deal, don't worry, nothing fried. You won't see anything happen. Right now you see that the satellite is basically dead, nothing's going on. Now the transmitter's off, so what I'm going to do is I'm going to turn the transmitter on, and what's going to happen is once I turn the transmitter on and I go to transmitter setup and then bind, as soon as I see bind, what you'll see is that you see the lights on the V control start to flash now, the receiver. It's showing me the actual serial number of the V-bar. Okay, remember that 37860? There it is. Okay, so what we're going to do is you're going to actually scroll down to it, and you're going to hit select. It's going to bind, and then it's going to automatically enter. Once it connects, it's going to enter the setup because now we have a brand new setup. So we need to actually go through and set the helicopter up from this point. So now you can choose whatever helicopter you want. Whatever, if it's a Mikado, you can already set, and a lot of stuff is already done for you. But if in this case we have a helicopter that's not a Mikado, you want to select other, whatever size it may be, other 700, other 800, whatever, or scale helicopter. In this case, we're going to do other 700. When you click it, you go through and you want to make absolutely sure that the cables from the motor are disconnected so it doesn't spool up. And you want to make sure that nothing else is connected. Right now we have the blades off the helicopter, so it's not going to be an issue. You're going to hit load setup. And then what's going to happen is it's going to start the setup and go immediately to the original setup for the helicopter itself. I'm going to let that load, and then it shouldn't take here but a second, and then we'll just start the setup and show you how to go. Okay guys, setup is ready to go. It's on and connected, and we're in the actual setup mode for the V-bar. So right now, it's just like the computer software. It's just going to ask you a bunch of questions. All you do is answer them exactly how you would do on everything else. So right now, this first part is asking you which way is your sensor facing. Is it upside down or right side up with the wire to the front of the rear? In this case, the V-bar sensor is going to be facing the rear of the helicopter, and it's right side up. So we need to go and we need to actually change that. So right now it's face up with the wire to the rear, which is exactly what it is. If you wanted to change, you would go to whatever you want to change, and you see the actual picture changes as well. Face up, wire to the rear is what it is, so that's what we're going to connect. The next one is we're going to select the type of swatch plate you have. HR3, if you look at the picture, it's just asking you where the actual servo is connected to the swatch plate. Not where the servo is on the helicopter, where is it connected to the swatch plate. In this case, it's HR3 because the servo is in the rear. So you would go through and you plug the servos into each individual channels. You'll see the numbers, channels 1, channel 2, and channel 3. So channel 1 is elevator, channel 2 is the left aileron, channel 3 is the right servo, which is pitch or right aileron, depending on what you want to call it. So that's correct. We're going to go from here. It's asking if we have clockwise rotation or counterclockwise rotation. We know it's clockwise in this helicopter, so we're going to choose clockwise. Do you have leading edge control or you have trailing edge control? Which means where is the where is the linkage to the head connected to in relation to where the blade is? On this helicopter, it's on the leading edge. So when the helicopter spins, the actual input is given on the leading edge of the blade. So that's what we're going to choose. So now it's asking the servos. Now, all this is asking is, are the servos going in the right direction? Okay guys, so what you can see right now is you see that all you want to do is check and see what servos are going in the wrong direction. When I move the stick up, the two circulate servos are going, or the two right and left servos in the front are going correctly, but the elevator is going backwards. So all you have to do is go down to the elevator servo, which in this case is channel 1, reverse it, everything goes up like it should be, and you notice now the directions of the ailerons and everything else is correct as well. So once you get that one part right, everything else will fall into place. If it doesn't, that means you have the servos plugged into the wrong spots. So you need to make sure that you have those correct. Okay, so now that is done, we're going to go to the next thing, which is the actual leveling of the swatch plate. With the new V-bar control and everything, the way it's set up with the new software in the V-bar, all you have to do is get the swatch plate as relatively flat as possible. It doesn't have to be perfect. It just has to be close to center and close to level as possible. So what you can do is you actually look at the squash plate now, and if you look at all the sides, that squash plate looks pretty good. And if you move the stick up and down, nothing happens because right now it thinks it's in the center point. So right now that's actually in really good shape. But let's say if I wanted to adjust the aileron for whatever reason, you can actually adjust the aileron. You'll see it going up or down and changing the aileron however you need it to be. Right now I'm going to change everything back to 0 and clear all because that was perfect to begin with. Okay, and we're going to say that that's good and it's ready to go. Okay, so the next one now is collective. So all you need to do is you put a pitch gauge on and you decide on how much collective you want to do. Let's say if you want to run 13 degrees of pitch, all you do is you move the stick all the way up and you adjust the top positive collective number to give you the pitch you want it to be. Whether it's 80 or between 80 and 100 is where it should be. That means that all your geometry is correct as far as the helicopter is concerned. And then you do positive, and then you move the switch thing down to negative, and you adjust the negative to get the same pitch on both sides, top and bottom. Okay, so we're going to do that a little bit later. So with the blades on the helicopter. So I'm going to skip to the next thing. Now this is the cyclic value. This is what V-bar thinks is 8 degrees when you flip the switch. It has nothing to do with how much actual pitch you're setting for cyclic. It's just a reference point. It's asking where 8 degrees is. So when you hit the cyclic value, what you'll see the actual helicopter switch to what the V-bar thinks is 8 degrees. Switch back to normal. That's 8 degrees. So you put your pitch gauge on and you measure it with the blades perpendicular, parallel to the boom, and you actually check and see what the pitch is. It's just a reference point. So if it's at 7 degrees, you adjust it up until you get 8 degrees, and if it's at 10 degrees, you adjust it down to you get to 8 degrees. As long as that number is between 80 and 100, you're good to go. That means your geometry is correct. If the number is too high, like if you have to go all the way up to like 120 to get to 8 degrees, that means you need to move the balls out on your servos one spot and then try again. If the number is too low, like if you're at 60 and you're already at 8 degrees, that means the balls are too far out. They need to move in to be closer to the spline of the servo, and that'll get the geometry closer to where it needs to be. It all needs to be within that range so that all the control loop works like it should. If you get outside of that, you'll start to get bobbles and things that you'll never be able to diagnose. You'll have all kind of adjustments that you're trying to adjust to get it right, and it'll never be perfect. So just make sure that that's where it needs to be within 8 degrees at 0 to 100. The next is the tail. So now we need to select what tail servo we have. So what you do is you go to select tail servo, and you're going to select what frequency that tail servo is. Okay, so that's a 333 760 microhertz tail, so we're going to select that. So now the tail is active. So when you do back and forth, you see it's barely moving as I'm moving the stick. It's not moving much at all. Okay? So how we're going to adjust that is you hold the stick to the left. If you're going to check and see the direction first. Okay. You're going to set your limits. Let's go and set the limits first while we're doing that. So right now, left limit, you move it until you get that, until you hear the binding of the tail servo, and then you back it off just a little bit. Okay. All right, then you go the other way. How you know if you have a good mechanical setup is if those 2 points are in between 10 points, 104 and 112. That's 8 points, that's good. So you know your mechanical setup is good to go. So everything else should be good to go as long as your endpoints go how you want them to be. Now, this is a way to tell if the helicopter, the tail setup is correct and if it's functioning as it should. Okay. Right now, if you notice, the tail is spinning backwards. Okay, when I do clockwise with the head, the tail spins backwards. It spins up into the rotor wash, which means the leading edge of the blades is going to be the front part of the tail right here in the front. That means that's where the fat part of the blade is going to be, is up here. So what you want to do is you want to check the leading edge. If you follow, the trailing edge of the blades, which is the skinny part, the back. You're going to follow that no matter what you do. So we know that the leading part is here because it spins around. Remember I told you it goes around up into this. This is the leading edge. That means this part is going to be the trailing edge, the skinny part of the blade. So when you move the sticks to the left, the trailing edge, this part, the skinny part of the blade, should go to the left as well. It doesn't matter which way the tail is spinning. It doesn't matter what side the helicopter is on. What side the tail is on. If the trailing edge goes left, right now it's going right. Correct. So what you need to do is we need to reverse the tail. So you go up to reverse. And reverse the tail. So now we go left. You see the trailing edge is going left. Okay, left. When you go right, it goes right. Okay. So now we have the end point set and we have the tail correction set as well. Now when you actually go to check the direction of the gyro, you'll know it's correct is when you pick the helicopter up and you watch the trailing edge. When you move the tail of the helicopter, not the nose, the tail of the helicopter, when it goes left, the trailing edge should go left. When you move it right, the trailing edge should go right. So as long as you follow that and it does that on every time, it doesn't matter if it spins forward, spins backwards, or if it's on the right side of the helicopter or left side of the helicopter. As long as you follow those guidelines, the tail will be perfect every time. It'll be right. Okay, so now we need to decide on the governor. Right now, you got a choice of the external governor, which is going to be the governor inside the ESC, the V-bar E governor, which is the V-bar Gov, and the V-bar Nitro governor, which is V-bar Gov for Nitro. Right now, this is Contronic ESC, so we're going to set this up for the V-bar governor, external governor, so that's correct. Everything is done. Okay, so basically your setup is done at this point. Now you can go set your endpoints on the ESC, and then everything's ready to fly at this point.